today's video, we're going to look at all the different kinds of angles that can happen in the circles. So the first one is a review. What we're going to do is we're going to look at what happens if the vertex of your angle is coming from the center of your circle. So in this case, K is the center of the circle. The vertex of that angle is coming from the center. We've talked about this quite a few times. This is called a central angle. And the central angle and the intercepted arc are congruent. So if the angle is 44, then the arc is going to be 44. The next kind of angle that we've already talked about is what happens when the vertex is on the circle. So here's my angle, and I see that the vertex is on the circle. This is called an inscribed angle. And remember that we trace the rays that form that angle out, and that creates that intercepted arc. The angle is going to be half of that intercepted arc, which is going to make that angle there 90 degrees. So in this case, x is going to be equal to 90 degrees. We've talked about those two different relationships. So what happens if the vertex is the center or on? The other two cases are when it's inside versus outside. And we're going to have two different formulas for this. So here, x is the angle that we're trying to solve for. That vertex is on the inside, but it's not the inside where it's at the center. If it's at the center of the circle, it's a central angle. But this is inside the circle, not at the center. So if I look at this angle right here, if I follow those sides out, it creates an intercepted arc. Now I have a vertical angle on the other side that also creates that intercepted arc. So our formula here is when I look at these, intercepted arc, the angle x, we are going to add the intercepted arcs together and cut it in half. We're going to divide that by 2. So 60 plus 104 cut in half. 60 plus 104 is 164 cut in half, and that's going to give us 82. So our missing angle x is equal to 82 degrees. So we add the intercepted arcs together, cut them in half. Now when we look at our last one here, the vertex is outside the circle. When I look at that vertex outside that circle, that angle, again, is formed by two rays. And those two rays are actually going to create two intercepted arcs. We create an intercepted arc on that side of the circle, as well as this side of the circle. Now our formula for this one is very similar to the last. When it is outside, that missing vertex angle is the big intercepted arc minus the small intercepted arc cut in half. So big arc minus small arc cut in half. 95 minus 27 is 68. Cut in half is 34. So that missing arc there is going to be 34 degrees. So our angle can occur in 4 different locations. It can come from the center of the circle, which is review. They are equal. It can be on the circle. The angle is half the arc. It can come from inside the circle. We add the two intercepted arcs, divide by 2. If it's outside, it's the big arc minus the small arc, divided by 2. All right, and that is it for this video.